So this is called mathematical induction. For all of your seniors who are ditching today, you're in big trouble, and you better learn this. Yes, that means you. All right. So, anyway, mathematical induction is a way to prove that certain sequences add up to a formula. It's a way to prove formulas, more or less. So, for example, say I have this sequence 1 plus 3 plus 5 plus, what comes next? 7 plus dot, 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 2n minus 1 plus 1, right? 2n, that 2n, that's 2n, n equals 1, 2n minus 1, okay? Isn't that 2n minus 1? Because this is n equals 1, 2, 3, 4. It turns out that the sum of this sequence is equal to n squared. Okay, so if I added up all these terms, right? For instance, the first 3 terms, right? 1 plus 3 plus 5 is equal to what? 1 plus 3 plus 5 equals 9, and 3 squared is also equal to 9, because that's the third term, right? And 1 plus 3 plus 5 plus 7 is equal to 16, and 4 squared is equal to 16. So that's always going to be true, we think, okay? Mathematical induction, the way you do it is there's like 3 things that you have to do, okay? The first thing that you want to do is, number 1, you show formula is true. Formula is true for n equals 1. Okay? And that's pretty easy to do in this case. And 2, okay, you assume so the next thing you do is that assume true for k equals 1 and prove true for, it's hard to write on these lines, for the next term which is going to be n equals k plus 1. Okay? So let me just show you the way this looks with this particular sequence. So first I'm going to say let n equals 1. So when I plug in 1 in this formula, what's the sum of the first 1 terms in this sequence? 1. And what's 1 squared? 1. So is 1 equal to 1 squared? Is 1 equal to 1 squared? Mm-hmm. Yes, so that checks out. Right? So now you assume it's true for k equals 1. So what you do is you say that 1 plus 3 plus 5 for, sorry, that shouldn't say k equals 1. That should say n equals k. I'm sorry. For n equals k. N equals k. So 1 plus 3 plus 5 plus dot, 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 okay? This is the kth term, okay? Equals k squared, okay? So we're assuming that this formula, whoops, that should say 2, I'm sorry, I'm just kind of this is true. Okay? So the next term, for the next series of numbers, okay, it's going to look like, I'm going to change colors. 1 plus 3 plus 5 plus, we're going to go dot, 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 2k minus 1 plus the next term. What I'm going to do is I'm going to take the next, if this is the term k, what would be the next term in that sequence? K plus 1. So what I'm going to do is I'm going to take k plus 1 and plug it into this formula right here. Okay? So the next term is going to look like 2 times k plus 1 minus 1. And I want to show that that's equal to not k plus 1 squared. I mean not k squared, but k plus 1 squared. You understand what I did? Okay? So this is like the same thing up to here, but the next term, I'm going to take k plus 1 and plug it into this formula. And I want to show that that is equal to what I get when I plug k plus 1 in here, which becomes this. Okay? Now the trick here is you're kind of cheating, but what you do is you call this thing, this part from here to here is equal to what? If you assume this is true. Assume that this is true. What do you assume that this is equal to? K squared. Do you see this? This plus this plus this plus this. You're assuming that that is indeed equal to k squared. So this is equal to k squared plus 2 times k plus 1. And you want to show that that's equal to k plus 1 squared. So that's the hardest step for people to realize. What you have to do is you assume it's true for n equals k. And then you go up to the next term where you're plugging k plus 1 in here. And you're plugging k plus 1 on this side of the formula. And then you just do algebra to show that that's true. Yes?
You missed the minus 1. Yeah, why?
Why? Where did I miss it? Oh! I'm sorry. So I missed a minus 1. Thank you. Okay. There should be a minus 1 right here. Minus 1. That would have messed me all up. K plus 1 squared. Okay, so now you want to show that this side of the equation equals that side of the equation. And that's pretty easy to do. K squared plus 2, that should be a 2k plus 2 when I distribute, minus 1. And that's equal to, when I FOIL this out, I get k squared plus 1k times 1k twice, right? 2k plus 1. And this simplifies to k squared plus 2k plus 1. And that's equal to k squared plus 2k plus 1. So what I just did is once again, I showed that it's true for n equals 1. I assume that it's true for n equals k. Then I go up to the next term, okay? And I substitute in what I assume to be true, and then using some algebra and simplification, I can prove that the left side is equal to the right side. Okay? It's a little tricky. It can get trickier, but on a test I won't give you like really hard ones. I'll give you relatively easy ones. Here's another one. Okay? So, ready for more? Should I keep writing on lined paper? Is that okay? I should choose a different color. I like this one. So let's show that 1 plus 2 plus 3 plus 4 plus dot 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 n. Is that it? That's n. That's equal to, does anyone remember what the formula for this is? 1 plus 2 plus 3 plus 4? That's equal to, this is one of those summation formulas that I gave you, n times n plus 1 divided by 2. Okay? Show that this is equal to that. So if I add together the first 4 terms, 1 plus 2 plus 3 plus 4, right? That's 7, 9, 10, right? And I want to show that if I plug in 4 in here, 4 times 4 plus 1, which is 5, right? 4 times 5 divided by 2 is also equal to 10. You get that? Okay. So now we're going to show that it's true for n equals 1. Okay, so step 1, show true for n equals 1. So that's what I'm going to do. I'm going to go, the sum of the first term, I want to see is that equal, the sum of the first term is just 1, right? And then I'm going to plug in 1 times 1 plus 1 divided by 2. Is that equal to 1? 1 times 2 divided by 2, is that equal to 1?
Yes.
Yes, so that works. Okay, so that's my first step. Okay? Now I want to assume that it's true for n equals k. So I'm going to go 1 plus 2 plus 3 plus 4 plus dot, 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 dot plus k equals k times k plus 1 divided by 2. Okay, so I'm going to assume true. Assume true. So the next thing I'm going to do is go to the next term in this sequence. Okay? So the next term in this sequence is going to be, or series, sorry, 1 plus 2 plus 3 plus 4 plus dot, 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 k plus, after I go to k, the next thing is going to look like what? What's the k plus 1, right? K plus 1. And now, what I'm going to do is in here, I'm going to plug in k plus 1. Okay? So up here, instead of being k times k plus 1, that's going to look like k plus 1 times what? K plus 2, right? Because that's, if I plug in k plus 1 in here, I get k plus 2, and that's k plus 1 divided by 2. Okay? And now I take this big chunk of stuff right here, and I sub this in for this, okay, in here. So I'm going to take this big chunk and sub it in here. So what I get is 4. So now what I get is k times k plus 1, whoop, yeah, k times k plus 1 divided by 2 plus k plus 1. I want to show that that is equal to k plus 1 times k plus 2 divided by 2. And now it's just an algebra exercise. Once you get there, all you have to do is do some algebra, okay, to show that it's true. So you can kind of put a little question mark. Is this true? Does everyone see where I got that from? Okay? Okay. So how can I get rid of this 2 here on both sides? Yes, sir.
Okay, so how did you know to just replace it with the k and not the k plus 1 again?
How did I know? Here?
No, above it.
Up, up
No, down. Left.
here?
Yeah, right there.
Because, so this is this sequence all the way up to here, right? So the next term after the kth term, right, would just be k plus 1, right? Because each term is going up by 1, okay? So now I just do algebra, and I'm going to multiply everything by 2, okay? And when I multiply everything, why didn't that change colors? Change colors. I didn't change colors. Oh. Okay, let's multiply everything by 2. So I multiply everything by 2, that makes that 2 go away. So I get k times k plus 1. And I have to multiply this by 2 plus 2k. And I have to multiply this by 2 plus 2 equals, and when I do that, this 2 gets away, k plus 1 times k plus 2. Okay? And then I multiply things together, so this gives me k squared plus k when I distribute, plus 2k plus 2, right? Which is equal to k squared plus 3k plus 2. And if I FOIL this out, I think I also get k squared, right? This times this gives you 1k, this times this gives you 2k, so that's plus 3k plus 2. So what I have shown is that the left side is equal to the right side using that process. Okay? Follow that? So you're kind of assuming, first you have to show it's true the first term, then you assume it's true for the second term, and then you prove it's true for the next term. Okay? So here's one more which is a little bit different and has a trick involved. Okay? And then we'll be done. Where did my recorder go? Where's my recorder? Are we still recording? Still recording. Okay. So let's see. Can I go back? Can I get a new piece of paper? So this one's kind of weird because it says show. I like this one because it's kind of a dirty trick one. Okay. Show that 3n minus 1 is divisible by 2 for all natural numbers. You know what natural numbers are? You know what all natural numbers are? Yeah. Now those are numbers that they don't need any preservatives or anything like that. They don't contain any free range numbers. Yeah, exactly. No, all natural numbers are the counting numbers like 1, 2, 3, 4, 5, 6, 7, 8. So the first thing we're going to show that it's true for n equals 1. So if I go for n equals 1, I'm going to plug in 3 to the 1 equal 3 to the 1 minus 1. That's equal to 3 minus 1, which is equal to 2. Is that divisible by 2? Yes. Okay? So that checks. Now I'm going to assume that it's true. Assume true, okay, for n equals k. So I'm going to assume that 3 to the k minus 1 is divisible by 2. Is divisible by 2. And then the next thing I have to go to the next term. So the next term is going to look like 3 to the k minus 1. Yes? Okay, 3 to the, no, that's wrong. 3 to the k plus 1, right? Minus 1. That would be the next term. Wouldn't it be? Show that 3 to the n minus 1 is divisible by 2 for all natural numbers. Okay? So the next term after 3 to the k would be 3 to the k plus 1 minus 1. So I want to show that that is divisible by 2. So this is where I got to cheat and look at my notes. Okay? So I'm going to say that this is equal to, and I'll show you why they do this. This is equal to 3 to the k plus 1 minus 3 to the k plus 3 to the k minus 1. And you'll see why they did this. How much is this equal to? Minus 3 to the k plus 3 to the k. What's minus 3 to the k at plus 3 to the k? 0, right? So I really haven't done, whoops, that should be 3 to the k. I'm sorry, 3 to the k. Okay? So I really haven't changed this at all. Okay? And now, what they do here is they rewrite this as 3 to the k times, they factor out 3 to the k. Okay? So you're going to have to watch closely.
Good morning,
No.
everyone. Please pardon the interruption. Due to technical difficulties, the names of those who made the cut for the 360 crew for the 2012-13 school year will not be posted on the 360 page on the Monarch website until tomorrow. Thank you for your understanding.
3 to the k minus 1. Here we go. Plus 3 to the k minus 1. So you're going to say, what the heck did I do here? What I did, this times this gives you this, right? 3 to the k. So you just kind of have to know this trick. 3 to the k times 3 to the 1 gives you 3 to the k plus 1, because you add the exponents. 3 to the k times negative 1 gives you negative 3 to the k, right? And then I leave this over here by itself. What's 3 to the k? That's 3 to the k times what? What's 3 to the 1 minus 1? 2, right? Okay? Plus 3 to the k minus 1. Well, I know that what's true about this? What's true about 3 to the k minus 1? About 3 to the k minus 1, that's kind of confusing. 3 to the k minus 1 is divisible by 2, right? Because I assume that that is true. What has to be true about this too? Is this divisible by 2? Yes, this is divisible by 2. So what has to be true about the whole thing? The whole thing is divisible by 2. Okay, so that's kind of confusing, I know. But there isn't much homework. Page 862, 862, 1, 3, 5, 6, 9, and 23. See what you can do with those, okay?